Namaste. Dear viewers, welcome to the lecture series on food technology. The topic today will be discussed is beer under the following subunits. 1. Introduction. 2. Types of beer. 3. Raw materials used for brewing. 4. Brewing process. At last, 5th. Sorghum beer. Introduction. Beer is an alcoholic beverage produced by the saccharification of starch and fermentation of the resulting sugar. The starch and saccharification enzymes are often derived from malted cereal grains, most commonly malted barley. Most beer is also flavored with hops, which add bitterness and act as a natural preservative, though other flavorings such as herbs or fruit may occasionally be included. The brewing process causes a natural carbonation effect, although forced carbonation is also used. The preparation of beer is called brewing. Beer is sold in bottles and cans, and in pubs and bars is available on draught. The strength of beer may be measured by the percentage by volume of ethyl alcohol. Strong beers are in excess of 4%, the so-called barley wines 8 to 10%. Diet beers or light beers are fully fermented, low carbohydrate beers in which enzymes are used to convert normally unfermentable and high calorie carbohydrates to fermentable form. In low alcohol beers, that is 0.5 to 2% alcohol, and alcohol free beers less than 0.1% alcohol. Alcohol is removed after fermentation by low temperature vacuum evaporation or by membrane filtration. Other low alcohol products may be produced from worts of low fermentability using yeast that cannot ferment maltose or by mixing yeast separated from a normal fermentation with weak wort at a low temperature for a short time. Before 6000 BC, beer was made from barley in Sumer and Babylonia. Reliefs on Egyptian tombs dating from 2400 BC show that barley or partly germinated barley was crushed, mixed with water and dried into cakes. When broken up and mixed with water, the cakes gave an extract that was fermented by microorganisms accumulated on the surface of fermenting vessels. The basic techniques of brewing came to Europe from the Middle East. In 1420, beer was made in Germany by a bottom fermentation process, so called because the yeast tend to sink to the bottom of the brewing vessel. Before that, the type of yeast used tend to rise to the top of the fermenting product and was allowed to overflow or was manually skimmed. Brewing was a winter occupation and ice was used to keep beer cool during the summer months. Such beer came to be called lager. The term lager is still used to denote beer produced from butter fermenting yeast, and term ale is now used for top fermented British types of beer. The Industrial Revolution brought the mechanization of brewing, better control over the process with the use of thermometer and saccharometer was developed in Britain and transferred to the continent, where the development of ice making and refrigeration equipment in the late 19th century enabled lager beers to be brewed in summer. In the 1860s, the French chemist Louis Pasteur, though his investigation of fermentation established many of the microbiological practices still used in brewing. The Danish botanist Emil Hansen devised methods for growing yeast in cultures free of other yeast and bacteria. This pure culture technology was taken up quickly by continental lager brewers, but not until the 20th century by the ale brewers of Britain. Meanwhile, German style lager bottom fermented by pure yeast cultures became dominant in the Americas. Brewing in the 21st century is a large scale industry. Modern breweries use stainless steel equipment and computer controlled automated operations, and they package beer in metal casks, glass bottles, aluminum cans and plastic containers. Beers are now exported worldwide and are produced under license in foreign countries. Coming to types of beers. The first type of beer is a bottom fermented beer. Bottom fermented beers are also known as lager beers because they were stored or lagered in cold cellars after fermentation for clarification and maturation. Yeast used in bottom fermented beers are strains of Saccharomyces uvarum. The types of bottom fermented beers are Pilsner beer. This is a pale beer with a medium hop taste. Its alcohol content is 3 to 3.8% by weight. Classically, it is lagered for 2 to 3 months, but modern breweries have substantially reduced the lagering time, which has been cut down to about 2 weeks in many breweries around the world. The water for Pilsner brew is soft, containing comparatively little calcium and magnesium ions. The second, Dortmund beer. This is a pale beer, but it contains less hops and therefore is less bitter than Pilsner. However, it has more body, that is, it is thicker and aroma. The alcohol content is also 3 to 3.8% and is classically lagered for slightly longer, that is 3 to 4 months. The brewing water is hard, containing large amounts of carbonates, sulfates and chlorides. Munich. This is a dark, aromatic and full-bodied beer with a slightly sweet taste because it is only slightly hopped. The alcohol content could be quite high, varying from 2 to 5% alcohol. The brewing water is high in carbonates but low in other ions. Weiss beer of Germany made from wheat and steam beer of California, USA are both bottom fermented beers which are characterized by being highly effervescent. Second type of beer, that is top fermented beers. Top fermented beers are brewed with strains of Saccharomyces cerevisiae. Among that, the first one is ale. Whereas lager beer can be said to be of German or continental European origin, ale, that is pale ale, is England's own beer. English ale is a pale, highly hopped beer with an alcohol content of 4 to 5% and sometimes as high as 8%. Hops are added during and sometimes after fermentation. It is therefore very bitter and has a sharp acid taste and an aroma of wine because of its high ester content. Mild ale is sweeter because it is less strongly hopped than the standard pale ale. When ale is produced in places with less suitable water, such as water may be Burtonized, that is by the addition of calcium sulfate. Second one, porter. This is a dark brown, heavy bodied, strongly foaming beer produced from dark malts. It contains less hops than ale and consistently is sweeter. It has an alcohol content of about 5%. And the third one, stout. Stout is a very dark, heavily bodied and highly hopped beer with strong malt aroma. It is produced from dark or caramelized malt. Sometimes caramel may be added. It has a comparatively high alcohol content, that is 5 to 6.5%, and is classically stored for up to 6 months. Fermentation sometimes proceeding in the bottle. Some stouts are sweet, being less hopped than usual. Next, the raw materials used for beer production. The raw materials used in brewing are barley malt, adjuncts, yeast, hops, and water. Coming to barley malt. As a brewing cereal, barley has the following advantages. Its husks are thick, difficult to crush, and adhere to the kernel. This makes malting as well as filtration after mashing much easier than with the other cereals such as wheat. The second advantage is that the thick husk is a protection against fungal attack during storage. Thirdly, the gelatinization temperature, that is the temperature at which the starch is converted into a water soluble gel, is 52 to 59 degrees Celsius, much lower than the optimum temperature of alpha amylase, that is 70 degrees Celsius, and as well as of beta amylase 65 degrees Celsius of barley malt. Next raw material, adjuncts. Adjuncts are starchy materials which were originally introduced. Starchy adjuncts, which usually contain little protein, contribute after their hydrolysis to fermentable sugars, which in turn increase the alcoholic content to the beverage. Adjuncts thus help bring down the cost of brewing because they are much cheaper than malt. They do not play much part in imparting aroma, color, and taste. Starch sources such as sorghum, maize, rice, unmalted barley, cassava, potatoes can or have been used depending on the price. Corn grits, that is defatted and ground, corn syrup and rice are most widely used in the United States. Since adjuncts contain little nitrogen, all the needs for the growth of the yeast must come from the malt. The malt bar adjunct ratio hardly exceeds 60/40 ratio. Hops. Hops are the dried cone-shaped female flowers of hop plant Humulus lipulus, which are also called with the other synonyms such as Humulus americanus, Humulus heomexicans, Humulus cardifolius. The importance of hops in brewing lies in its resins, which provide the precursor of their bitter principles in beer, and the essential oils which provide the hop aroma. In the original Pilsner beer, the amount of hops added is about 4 gram per liter, but smaller amounts varying 0.4 to 4 gram per liter are used elsewhere. The addition of hops has several following effects. Originally, it was to replace the flat taste of unhopped beer with the characteristic bitterness and pleasant aroma of hops. Hops have some antimicrobial effects, especially against beer sarcina, which is popularly called Pediococcus damnosus, and other beer spoiling bacteria. Due to the colloidal nature of the bitter substances, they contribute to the body colloidal stability and foam head retention of beer. The tannins in the hops help precipitate proteins during the boiling of the wort. These proteins, if not removed, cause a haze, that is chill haze, in the beer at low temperature. Water, one of the most essential part of the raw material. The mineral and ionic content of the pH of the water have profound effects on the type of beer produced. Some ions are undesirable in brewing water. Nitrates slow down fermentation, while iron destroys the colloidal stability of the beer. In general, calcium ions lead to a better flavor than magnesium and sodium ions. Calcium and bicarbonate ions are most important because of their effect on pH. Water is so important that the natural water available in great brewing centers of the world lent special character to beers peculiar to these centers. Brewers' yeast. Yeast in general will produce alcohol from sugars under anaerobic conditions, but not all yeast are necessarily suitable for brewing. Brewing yeasts are able, besides producing alcohol, to produce from wort sugar and proteins a balanced proportion of esters, acids, higher alcohols and ketones, which contribute to the peculiar flavor of beer. The two types of brewer's yeast used commonly in brewing process are Saccharomyces cerevisiae and Saccharomyces euarum, that is the top and bottom fermenting yeast respectively. Yeasts are used after fermentation for a number of times which depend on the practice of the particular brewery. Mutation and contamination are two hazards in this practice, but they are inherent in all inocula. Coming to the brewing process. Beer production involves malting, milling, mashing, extract separation, hop addition and boiling, removal of hops and precipitates, cooling and aeration, fermentation, separation of yeast from young beer, aging, maturing and packaging. The object of the entire process is to convert grain starches to sugar, extract the sugar with water and then ferment it with yeast to produce the alcoholic lightly carbonated beverage, that is beer. Coming to the first step, malting. Malting modifies barley to green malt, which can then be preserved by drying. The process involves steeping and aerating the barley, allowing it to germinate, and drying and curing the malt. In order to ferment by yeast, the food reserve of barley, that is starch, must be converted into a simple sugars by enzymes such as alpha and beta amylases, which carry out the conversion. Malting begins by immersing barley harvested at less than 12% moisture in water at 12 to 15 degrees Celsius for 40 to 50 hours. During this steeping period, the barley may be drained and given air test, or the steep may be forcibly aerated. As the grain imbibes water, its volume increases by about 25% and its moisture content reaches about 45%. Germination. In traditional malting, the steeped barley was placed in heaps called couches and after 24 hours spread on a floor to permit germination, because respiration of the grain causes oxygen to be taken up and carbon dioxide and heat to be produced. Control of aeration, ventilation and temperature was achieved by manually turning the grain. Large scale floor maltings with mechanical turners were introduced, later replaced by pneumatic maltings, in which germination occurred in boxes with the bed automatically turned, aerated and ventilated with forced air. In some malting operations, gibberellic acid is sprayed onto the barley to speed germination and bromates are used to suppress rootlet growth and malting loss. Kilning. The first stage of kilning, a high flow of dry air at 50 degrees Celsius for lager malt and 65 degrees Celsius for ale malt is maintained through a bed of green malt. This lowers the moisture content from 45 to 25%. A second stage of drying removes more firmly bound water, the temperature rising to 70 to 75 degrees Celsius and the moisture content falling to 12%. In the final curing stage, the temperature is raised to 75 to 90 degrees Celsius for lager and 90 to 105 degrees Celsius for ale. The finished malt is then cooled and screened to remove rootlets. Mashing. After kilning, the malt is mixed with water at 62 to 72 degrees Celsius and the enzymatic conversion of starch into fermentable sugar is completed. The aqueous extract, that is wort, is then separated from the residual spent grain. Milling. The efficient extraction with water, malt must be milled. The object is to retain the husk relatively intact while breaking up the brittle, modified starch into particles. Mixing and mashing. Traditionally, mashing may be one of the two distinct types. The simplest process, infusion mashing, uses a well-modified malt, 2 to 3 volumes of water per volume of malt, a single vessel and a single temperature in the range of 62 to 67 degrees Celsius. With well-modified malt, breakdown of proteins and glucans has already occurred at the malting stage, and at 65 degrees Celsius the starch readily gelatinizes and the amylases become very active. Less well modified malt, however, benefits from a period of mashing at low temperature to permit the breakdown of proteins and glucans. This requires some form of temperature programming, which is achieved by decoction mashing. After grist is mashed in at 35 to 40 degree Celsius, a proportion is removed, boiled and added back. Mashing with 2 or 3 of these decoction raises the temperature in stages to 65 degree Celsius. The next most important process is boiling and fermenting. Boiling. After separation, the wort is transferred to a vessel called the kettle or copper for boiling, which is necessary to arrest enzyme activity and to obtain the bitterness value of hardened hops. Hops. Several varieties of the hops are selected and bred for the bitter and aromatic qualities that they lend to brewing. The female flowers or cones produce tiny glands that contain the chemicals of value in brewing. Humulones are the chemical constituents extracted during the wort boiling. Traditionally, the dried hop cones are added whole to the boiling wort, but powdered compressed hops are often used because they are more effectively extracted. In addition, the hop components may be extracted by solvents such as liquid carbon dioxide and added in this form to the wort or after isomerization to the finished beer. Heating and cooling. The kettle boil lasts 60 to 90 minutes, sterilizing the wort, evaporating undesirable aromas and precipitating insoluble proteins known as hot break or trub. Trub and spent hops are then removed in a separator where the hop cones from the filter bed. clarified wort is cooled formerly in a shallow troughs or by trickling down an inclined cooled plate, but now in a plate heat exchanger. Oxygen is added to this stage and the cooled wort passes to fermentation vessel. Coming to fermentation process. In this most important stage of the brewing process, the simple sugars in wort are converted to alcohol and carbon dioxide, and green, that is young beer, is produced. Fermentation is carried out by yeast, which is added or pitched to the wort at 0.3 kg per hectoliter, yielding approximately 1 crore cells per milliliter of wort. In brewing, it is traditional to refer to ale yeast used predominantly in top fermentation as top strains of Saccharomyces cerevisiae, and to lager yeast as bottom strains of Saccharomyces cahlbergensis. Maturation and packaging. This is the last step of brewing. A slow secondary fermentation of residual or added sugar called primings, or in lager brewing, the addition of actively fermenting wort generates carbon dioxide, which is vented and purges the green beer to undesirable volatile compounds. Continued yeast activity also removes strong flavoring compounds such as diacetyl, allowing pressure to build up in the sealed vessel, then increases the level of carbonation, giving the beer its condition. In traditional brewing, large volumes of ale were conditioned in tanks for 7 days at 15 degrees Celsius, whereas lagers were matured at 0 degrees Celsius for up to 3 months. Beer produced on a large scale in modern breweries is kept free of oxygen, which ultimately spoils beer, filtered through cellulose or diatomaceous earth to remove all yeast, and packaged at 0 degrees Celsius under pressure of carbon dioxide. Beer produced by high gravity brewing is diluted to the desired alcohol concentration immediately prior to packaging with oxygen free carbonated water. Most beers packaged in bottles or metal cans are pasteurized in pack by heating to 60 degrees Celsius for 5 to 20 minutes. Beer is also packaged into metal kegs of 50-liter capacity after pasteurization at 70 degrees Celsius for 5 to 20 seconds. At last, we will discuss about sorghum beers. Barley is a temperate crop. In many parts of the tropical Africa, beer has been brewed for generations with locally available cereals. The commonest cereal used is sorghum bicolor, which is also called sorghum vulgare, known in the United States as milo, in South Africa as Kafir corn, and in some parts of West Africa as Guinea corn. The cereal, which is indigenous to Africa, is highly resistant to drought. Sorghum is often mixed with maize, that is Gia maize, or millets, that is Penisatum species. In some cases, such as in Central Africa, for example Zimbabwe, maize may form the major cereal. Outside Africa, sorghum is not used normally for brewing except in the United States, where it is occasionally used as an adjunct. The method for producing these sorghum beers of the African continent as well as their nature is remarkably similar. They are all pinkish in color, sour in taste, and of fairly heavy consistency, imposed partly by starch particles, a lactic fermentation. At last, Conclusion: beer is the world's most widely consumed alcoholic beverage and the third most popular drink overall after water and tea. It is thought by some to be the most oldest fermented beverage. Thank you.